Hey friends, you're with Anthony, history reconstructor, and today we'll tell you the story of a construction called the Eighth Wonder of the World. A story about a bridge that cost $15 million, 27 lives, and the health of hundreds of workers. But before we begin, hit subscribe, because what you're about to learn about the Brooklyn Bridge will change your understanding of the price paid for progress in the 19th century. Imagine New York in the 1860s, the two largest districts of the city, Manhattan and Brooklyn, separated by the turbulent East River, 1,595 feet wide. Every day, dozens of ferries transported over 100,000 passengers across the river. But in the winter of 1867, the river froze so solid that ferries couldn't move for weeks. People were stranded on opposite sides of the city. Business stopped. And that's when everyone realized New York needed a bridge. But build a bridge across the East River, it seemed insane. The river was too wide, the current too strong, and ship traffic demanded that the bridge have no support in the middle of the river. The entire span had to be free. And then appears John Augustus Roebling, a 61-year-old German immigrant with a crazy reputation. This man had already built a suspension bridge across Niagara Falls, spanning 821 feet, and a bridge across the Ohio, spanning 1,057 feet. He invented a way to weave steel cables that were stronger than any chains. And now, he wanted to build a bridge 1,595 feet long between two towers, the longest suspension bridge in the world. In 1867, he was appointed chief engineer of the project with a budget of $5 million. Roebling promised to build not just a bridge, but a masterpiece. Two Gothic towers, 278 feet high above the water, four main cables 15.75 inches thick each, capable of supporting a weight of 18,700 tons. But he would never see his bridge. June 28, 1869, a hot summer day in Brooklyn. John Roebling stands on the edge of a wooden dock, making final measurements with a compass, determining the exact location for the future bridge tower. He's so focused that he doesn't notice a ferry approaching the dock. The ferry crashes into the dock. Roebling is crushed between two wooden beams. His right foot is smashed. Doctors amputate his toes. But Roebling refuses medical drugs. He believes in hydrotherapy and prefers to treat himself with water procedures. Over the next 3 weeks, tetanus spreads through his body. Spasms become increasingly severe. On July 22, 1869, John Roebling dies in terrible agony, never having seen the start of construction on his greatest project. He became the first of 27 people who would die during the bridge's construction. The board of directors convenes an emergency meeting. The project is in jeopardy. On January 2, 1870, construction of the Brooklyn Bridge officially begins. No one yet knows that the real cost will exceed $15 million, and no one knows about the true hell that awaits. The board of directors convenes an emergency meeting. The project is in jeopardy, but John's son, 32-year-old Washington Roebling, who studied engineering at Rensselaer Polytechnic Institute and worked with his father on the bridge design, declares, "I will complete my father's work." January 1870. The most dangerous part of construction began, the sinking of pneumatic caissons. These were enormous wooden boxes measuring 168 by 102 feet, the size of half a football field. They weighed 3,000 tons each and had to be lowered to the bottom of the East River so workers could dig to bedrock and establish foundations for the towers. Here's how it worked. The caisson was lowered to the river bottom. Compressed air was pumped inside at a pressure of 21 pounds per square inch, enough to displace the water and create a dry workspace. Workers descended through an airlock, a small chamber where pressure was gradually increased so a person could acclimatize. Now imagine you're one of these workers. You climb down a ladder into darkness. The air becomes thick, heavy. It presses on your eardrums so hard, it feels like your head will burst. The temperature inside the caisson reaches 80 to 90 degrees Fahrenheit. The air reeks of rot, mud, and sweat. You dig the river bottom, stone, sand, silt, decomposed animal remains. Above you are 45 feet of water and 3,000 tons of wood and stone. The only light comes from candles and gas lamps that barely burn in the compressed air. And sometimes fires break out, wood ignites, and you have to escape. Climb through the airlock before the entire caisson becomes a trap. Work shifts lasted 2 hours. During this time, you dug, removed dirt through special pipes, laid stone blocks. For such work, they paid double wages, $2 a day instead of the usual $1, because everyone understood this was deadly dangerous. But the most terrible thing began when you climbed back to the surface. And you know what's scariest? Doctors of that time didn't understand at all what was happening to the workers. They thought people were just faking to get compensation. At first, it was just complaints. A worker would surface after his shift and complain of nausea, dizziness, ringing in the ears. Then joint pain would begin, so severe that people screamed and writhed in agony. That's what they called it, the bends, because workers' bodies bent from spasms. Some workers lost vision in one or both eyes. Others couldn't move their arms or legs, and some simply dropped dead within hours of exiting the caisson. City physician Dr. Andrew Smith was appointed to monitor the worker's condition. He documented every case but couldn't understand the cause. He saw that the deeper the caisson sank, the more cases of illness occurred. But what exactly caused it? Today we know it was decompression sickness. When a person is under high pressure, nitrogen from the air dissolves in the blood. If you ascend too quickly, this nitrogen turns into bubbles, like when you open carbonated water. These bubbles block blood vessels, damage nerves, destroy joints. But in the 1870s, they didn't know this. Some doctors thought workers were faking. Others thought it was some infectious disease. By the end of 1871, the Brooklyn caisson reached a depth of 44.5 feet below water level. Over 100 workers fell ill with the bends. 3 died. Washington Roebling made the decision to stop further descent. Although the caisson hadn't yet reached bedrock, he didn't want more deaths. But the Manhattan caisson proved an even worse nightmare. It had to be lowered to a depth of 78.5 feet below water level, almost twice as deep as the Brooklyn one. Air pressure reached 35 pounds per square inch. At such pressure, a person could work a maximum of 1 hour without serious consequences. And it was during work on the Manhattan caisson that the greatest tragedy occurred. Washington Roebling wasn't a boss who sat in an office giving orders. He descended into the caissons more often than anyone else. He wanted to personally see every detail, check every inch of the structure. He spent 6 to 8 hours a day underwater. In 1872, during work on the Manhattan caisson, after another long day under 35 pounds of pressure, Washington surfaced. At first, he felt slight dizziness. Then came pain, terrible, paralyzing pain in his back and legs. Over the following days, the pain intensified. His legs gave out. Then his arms began to shake. His vision deteriorated so badly he was almost blind. Washington Roebling, the 35-year-old chief engineer of the century's most ambitious project, became disabled for life. Doctors told him he would never be able to work again. The board of directors began discussing his dismissal. The project that took his father's life and now destroyed his own health was on the verge of collapse. But there was one person who wasn't going to give up. And now attention, what you're about to learn will change your perception of 19th century women. Because for the next 10 years, the Brooklyn Bridge was built by a woman who never studied engineering. Emily Warren Roebling was an ordinary Victorian-era wife. She married Washington in 1865 when she was only 23 years old. She bore him a son, she managed the household, and now she watched her 35-year-old husband dying in bed from pain. At first, she just wanted to help. Washington would dictate instructions to her, and she would go to the construction site and relay them to assistants. But very quickly, Emily realized if she wanted to keep her husband in his position, she needed to understand what she was talking about. And she began to learn mathematics, physics, material resistance, stress analysis, catenary curves, steel properties, suspension bridge construction. She studied 10 to 12 hours a day, read engineering textbooks her husband brought her, asked him thousands of questions. Over the next 10 years, Emily became the de facto chief engineer of the project. Every morning she rode to the construction site. She inspected the work. She solved technical problems. She managed a team of hundreds of workers. She negotiated with steel suppliers. She signed contracts. She resolved conflicts between workers. When politicians and competing engineers tried to block the project, it was Emily who met with them and defended the bridge design. People began to gossip. Some said she actually developed the bridge design. Others were outraged. How could a woman manage such a complex project? But Emily was a diplomat. She always said she was carrying out her husband's orders, that she was just a mediator between the sick engineer and the workers. In reality, she made decisions independently. Washington was too ill to control all the details, but officially he remained chief engineer, because if the truth came out, he would be immediately fired, and a woman would never be appointed to this position. For 10 years, Emily Roebling fooled the entire system and built the world's greatest bridge. While the management drama unfolded behind the scenes, the bridge continued to grow. August 1875, the Brooklyn anchorage was completed, a massive stone structure 80 feet high, designed to hold 4 main cables. The weight of each anchorage, 60,000 tons. July 1876, the Manhattan anchorage was completed. 2 Gothic towers rose above the East River to a height of 278 feet, taller than any structure in the Western Hemisphere at that time. During tower construction, several workers died. One was killed by a falling stone that dropped from 200 feet. Another was swept by wind from the tower's top straight into the river. Yet another worker got stuck between moving beams and was crushed. In August 1876, engineer Farrington organized a demonstration ceremony to prove the bridge was safe. He stretched a temporary cable between the two towers and rode across it in a suspended box, 1,595 feet above the turbulent waters of the East River. Thousands of people watched from the shores, holding their breath. And then began the most complex part, laying the main cables. The technology John Roebling invented was revolutionary. Instead of using heavy chains, the bridge was held by 4 steel cables. Each cable consisted of 5,296 individual wires, 0.165 inches in diameter. The total length of wire in all 4 cables, 14,357 miles, enough to stretch from New York to Dallas. The process was painfully slow. Workers strung one wire at a time, running it from the Brooklyn anchorage, over the top of the Brooklyn Tower, down to midspan, up to the top of the Manhattan Tower, and to the Manhattan anchorage, then back to string the next wire, again and again, 5,296 times for each cable. In October 1878, during cable laying, a horrific incident occurred. One of the temporary cables suddenly snapped under tension. It whipped across the platform like a giant lash, killing 2 workers and maiming 3 more. But work continued. By August 1882, they began installing final elements: 114 intermediate cords, 72 diagonal stays, 60 vertical posts, numerous floor beams, bridge trusses. And finally, in early 1883, after 14 years of hell, the Brooklyn Bridge was almost ready. At 2 p.m., schools closed, workers were given the day off, stores shut their doors. Over 150,000 people gathered on the shores of the East River. President Chester Arthur arrived by special train from Washington. New York Governor Grover Cleveland, future U.S. President, led a delegation from Albany. But the first person to officially cross the bridge was Emily Roebling. She rode in a carriage, holding a live rooster on her lap, a symbol of victory. Behind her walked the president, the governor, the mayors of both cities, and a long procession of officials. Washington Roebling watched the ceremony from his Brooklyn Heights home window through a telescope. He was too ill to attend the opening of the bridge that took 14 years of his life and forever destroyed his health. President Arthur gave a speech. This is not just a bridge. It is a monument to human ingenuity, perseverance, and sacrifice. He didn't mention Emily Roebling by a single word. When the sun set, the sky erupted with fireworks. 500 rockets shot into the air. Light reflected off the bridge's steel cables, transforming it into a giant harp of fire. On the first day, 150,000 people crossed the bridge on foot. Some were afraid to step on it, believing such an enormous structure couldn't be safe. But the bridge held firm, just as John Roebling had promised 16 years earlier. In the first year, over 10 million pedestrians crossed the bridge. The toll was 1 cent for pedestrians and 5 cents for carriages. This money gradually recouped the construction cost, $15.5 million, 3 times the original budget. 27 workers died during construction, 3 suffocated in caissons, 2 were crushed by falling stones, 2 more were killed by a snapped cable. Others fell from towers. Some died from caisson disease at home, days after their shift. Over 100 workers suffered severe forms of decompression sickness. Many remained disabled for life, with destroyed joints, paralyzed limbs, impaired vision. The chief engineer himself lived another 43 years, but never recovered from the disease. He died in 1926 at age 89, living long enough to see his bridge become a symbol of New York. Emily Roebling lived until 1903. She never received official recognition for her work on the bridge. Her name wasn't engraved on the memorial plaque. In official documents, she appeared only as the chief engineer's wife. Only in the 21st century did historians begin investigating her true role and recognize her as the de facto chief engineer of the project. Today, the Brooklyn Bridge is a national historic landmark. It survived both World Wars, the Great Depression, the September 11th attacks. It withstood Hurricane Sandy in 2012, when winds reached 80 miles per hour. Every day, over 150,000 vehicles, 4,000 cyclists, and 10,000 pedestrians crossed the bridge. Most don't know the story of workers who suffocated in underwater caissons, of those who died from a mysterious disease doctors couldn't understand, of the engineer who gave his health for the bridge, of the woman who managed construction in the shadows because society didn't recognize female engineers. This isn't a story about a bridge. It's a story about the price paid for every great structure, about how behind every wonder of the world stand hundreds of unknown names, and about how sometimes the greatest heroes remain in the shadows, unrecognized and forgotten, until history finally reveals the truth. If you enjoyed this video, subscribe to Anthony History Reconstructor. We tell stories that change your understanding of the past. Hit the bell so you don't miss upcoming episodes about the most dramatic constructions in human history. See you next time, friends.